I am Dr. P. Usharani, Professor EEE Department, R&D Engineering College. I am going to handle a topic on closed loop speed control for VSI as well as cycloconvector induction motor drives. The PWM inverter has the capability for regenerative braking as well as 4-quadrant operation. And for closed loop control, always outer speed control loop and inner current control loop. For induction motor, here slip was used as a inner slip speed loop. This is the block diagram of closed loop circuit. Generally, the major advantage of I have mentioned inner current control loop, outer speed control loop. Here, for induction motor, the current is controlled by the controlling the slip. That's why here you are saying slip control. Okay. For induction motor, current is controlled by controlling the slip. So what are the benefits of, first of all, the inner current control loop? The major benefit are we can limit the converter current. Okay. First point, converter current as well as the motor current, or should keep the motor torque Tm must be below a safe limit. Okay, that is the major advantage of inner current loop. We can limit the converter current as well as motor current, or you can say the motor torque should be kept at below a safe limit. Okay. Second point is the performance, that is the drive performance of any non-linearities, okay, which is present in the converter motor system is there, means it reduces. So second major advantage, inner current loop is useful for reducing the effect of driver performance. So that is any non-linearities present in the converter motor system. Okay. So that's why we are choosing inner current loop and outer speed control loop. If you consider here in this circuit how it operates here is generally if you see the PWM inverter, which may be VSI fed inverter as or cycloconverter. Okay, both will be benefited for regenerative braking as well as 4-quadrant operation. So this PWM inverter is fed from a DC supply through the LNC or the filters used here. So how it operates, if you see, generally the speed error, okay, you are measuring the speed, motor speed error. How you are getting this speed error is the speed sensor senses the actual speed, which is compared with the reference speed omega m star, and the error is measured. Okay, this speed error is passed through the speed controller. So here the speed controller, we can use any type of controllers. Generally PA controller is preferred. Why PA controller is preferred is it gives a good steady state error, okay, and attenuates the noise. So these are the 2 points we are choosing PA controller. Both for speed controller as well as slip regulator, we are using PA controller. Here as we have got the speed error which is passed through the speed controller, that is PA controller. The major advantages, we can get a good steady state error and to attenuate the noise which is used. So the speed error is passed through the speed controller. And then the next is a slip regulator. What it does here is the slip regulator sets the slip speed command omega SL star. Okay, it will set the omega SL star. The maximum value of this is limited to the maximum value is limited to the inverter current. Okay, to the maximum permissible value for positive side as well as negative side. The slip regulator sets the maximum permissible value, and you are getting the synchronous speed. How you are getting omega MSS? This slip speed, okay, slip speed omega SL star, which is added with the omega M. Okay, omega M is actual speed measured using speed sensor. These two are added. That is your omega M as synchronous speed. Okay, so which determines the frequency of the inverter. So which determines the frequency of the inverter. So here the closed loop control, okay, closed loop control of the reference signal B star. Another controller we are using, voltage controller. So this B star is generated from the flux control, okay, which is generated from the flux control. So generally below base speed, okay, below base speed, constant flux operation, okay, constant flux operation. Above base speed, constant terminal voltage operation. Okay, generally we are choosing the operation below base speed, constant flux operation, okay, till base speed. Above base speed, constant terminal voltage operation. That's why we are choosing two parameters. Okay, so by using this frequency as well as the V, okay, the voltage controller, through the voltage controller, it generates the reference pulses for the PWM inverter. So how it works, you kindly see here. There are two conditions. Okay, one is whether your step increase in your omega SL, okay, step increase in your command, whether it is positive or negative. So first I am increasing the value of omega M star. Okay, there is an increase in omega M star speed command. So that means this value is more when compared to the actual measured value, means your error is positive. So you are getting positive speed error. So that time the omega SL star is set to the maximum permissible value I have already mentioned. So that means the drive will be acceleration mode. The drive accelerates fast manner at the maximum allowable inverter current, okay, which produces the maximum available torque till the speed error is reduced to a small value. Okay, so if speed error is reduced to a small value, the drive finally settles at a slip speed. That means it balances the motor torque as well as load torque. Okay, that is the condition when the speed error is positive. The ulta you have to mention for deceleration. Okay, that is the speed error. This omega M star, a step decrease in the speed command. Omega M star means this will be, the error will be that time negative. Okay, so you will be having negative speed error. Even that time the slip regulator, okay, that is the omega SL star, we set the maximum negative value. Okay, maximum negative value. So in the negative current means the drive must be deceleration mode. Deceleration means that is a regenerative braking. because regenerative braking power flows from your load to source side. That's why we are saying regenerative braking. Okay, at the time maximum permissible current and maximum allowable braking torque until the speed error goes to reduced to a small value. So it goes on continuing from motoring as well as braking, regenerative braking operation. It balances the motor torque as well as load torque. Okay. So that is the operation of closed loop speed control of uh, VSI fed or cycloconverter fed induction motor drives. So the major benefit here we can say the fast response is required. Okay, the fast response is required. So if fast transient response is not required means you should not take care current ratings of the inverter as well as the converter. So generally closed loop control are the benefits of in electrical drives. There are 3 points we can say. One is protection, second point enhancement, that is improvement of speed of the response, third point to enhance steady state accuracy. Okay, these are the 3 major points we are going for closed loop control in electrical drives. Okay, uh, thank you.